Question number 2 asks us, or tells us that a ladder is 20 feet long and is leaning against the side of a building. If the angle formed between the ladder and the ground is 75 degrees, so let's redraw the triangle down here so it's a little bit easier to see. This angle right here is 75 degrees. How far is it from the bottom of the ladder to the base of the building? So that's going to be my x. That's what I'm looking for. And the other thing that it tells me is that the ladder is 20 feet long. So let's go ahead and label everything in our right triangle. 20 is going to be my hypotenuse because it's across from the right angle. The side opposite of 75 is over here, and that doesn't give us a value. And the side that's adjacent to 75 is the side that's next to it. So this is going to be adjacent. So the two numbers that I have are the hypotenuse and the adjacent. I have the hypotenuse and I'm looking for the adjacent. So go ahead and write SOHCAHTOA to try to figure out which one of these we're going to use. We are going to use cosine because, again, I'm looking for the adjacent and I have the hypotenuse. So that's how we're going to use cosine. So I'm going to type in the cosine of an angle is going to equal adjacent over hypotenuse. And then to fill in everything else, I have the cosine of 75 is equal to the adjacent side, which is x, over the hypotenuse, which is 20. To get x by itself, multiply both sides by 20, and you end up with about 5 feet. To go on to the next section, 4 and 5, let's do number 4. It says a kite is flying at an angle of elevation of about 55 degrees. Ignoring the sag in the string, find the height of the kite if the 85 meters of string have been let out. So here's the 85, and I'm looking for x. So let's go ahead and label this. Here's my right angle, which means my hypotenuse is going to be 85, and the side across from 50 is going to be my opposite. So SOHCAHTOA, I have the hypotenuse, and I'm looking for the opposite. If I have the hypotenuse and I'm looking for the opposite, I'm going to use the sine. So now I'm going to have the sine of 55 is going to equal the opposite, which is x, over the hypotenuse, which is 85. To get x by itself, multiply both sides by 85. So you're going to do 85 times the sine of 55, and you will get about 70 meters. For the bottom section, questions number 6 and 7. Let's do question number 7. An observer at the top of a building sees a car on the road below. The angle of depression to the car is 28. What we do know is that this line right here and this line right here are parallel to each other. So if this angle is 28, this angle right here also has to be 28 because they are alternate interior angles. So they're both going to be equal to each other. If the car is about 50 meters from the building, how tall is the building? So again, I have my right triangle. Let's draw this down here just to be sure. This is going to be 28, excuse me. And the height of the building is what we're looking for, and we know the distance away is going to be 50. So let's start labeling everything I have. This is my right angle, this is my hypotenuse, x is my opposite, and 50 is my adjacent. So the two that I have are the adjacent and the opposite. Right, SOHCAHTOA. And I'm looking for the opposite, and I have the adjacent. So in this case, I'm going to use the tangent. So I'm going to have the tangent of 28 is going to equal the opposite, which is x, over the adjacent, which is 50. To get x by itself, multiply both sides by 50, and you will get x is equal to about 27.